Welcome to this explainer. Today, we're stepping completely away from the usual, finger-pointing stories of human error or bad intentions. Instead, we're going to look at something much more fundamental. We're examining the very architecture of complex systems and how rational, logical decisions made at a local level inevitably produce massive, unintended global failure. Our focus? Why systems inherently increase monitoring and how that exact mechanism systematically destroys honest reporting. Let's dive into this. There's this super common, almost universal belief in management and governance, right? The idea is if you increase monitoring, you naturally increase your control and understanding of a system. You expect total visibility. But looking at the actual data, we have to immediately contradict that assumption. When complex systems deploy heavy monitoring, the mathematical result isn't total visibility. The result is actually catastrophic. It's total blindness. The system creates its own massive blind spots. But to understand how a system does this to itself, we can't look at the end result first. We have to look at the structural drive. Section 1. The visibility contradiction. Let's look at how this structural drive for total information awareness actually begins to manifest. To really get this, let's picture a parallel physical system. Imagine a rigid, closed pipe network carrying a highly pressurized fluid. Now, to understand what's happening inside this network, the system operators need data. They need to measure the flow. And to get that data, they have to physically attach diagnostic sensor clamps right around the exterior of the pipe. So the system begins rationally enough. The operators attach 10 of these diagnostic sensor clamps at critical junctions. Now, just by their very physical design, these clamps have to slightly compress the exterior wall of the pipe in order to accurately read the internal data flow. Notice the immediate physical consequence of this action. We aren't even interpreting what the data means yet, we're just observing the physical reality. By adding 10 sensor clamps to extract data, the internal diameter of the pipe has been reduced by 4%. The system has slightly altered the very environment it's trying to measure. Section 2. The compression of flow. Let's shift from our physical pipe to real-world monitoring deployments and see how this exact same compression begins to happen in human networks. In real-world networks, the drive for data is literally immense. To monitor modern communication networks, massive automated systems are deployed to just continuously sift through absolute oceans of intercepted data, constantly looking for triggers. The system is firmly clamped onto the flow of information. And this data gathering extends right into physical space. Geographic locations are continuously extracted. By calculating exactly how long digital signals take to bounce between devices and surrounding towers, systems can map the physical movement of basically every component within the network. And this happens continuously, regardless of whether the device is actively in use. The sensors actually go even deeper than that, down to the biological level. Systems are now built to measure microscopic facial twitches, changes in your gait, and even the heat generated by blood flow to the face to assess a subject's stress levels. The physical, digital, and biological flow of the entire environment is constantly being measured. Which brings us to a really crucial behavioral consequence. Just like our pipe was physically compressed by the clamps, human behavior is compressed by observation. As theorists who analyze surveillance point out, the sheer presence of these monitoring structures functions to create a feeling in the subject of always being watched. The subjects within the system undergo a behavioral adaptation. They begin to self-police. They alter their flow to avoid triggering the sensors. Section 3. The elimination of error. Okay, so the system is gathering data, and the subjects are adapting. Now we're going to escalate the consequences as the system inevitably increases its data gathering footprint. Let's jump back to our physical pipe network. The operators decide they need higher resolution data. 10 clamps, just not enough to give a complete picture. So they escalate. They attach 50 sensor clamps across the pipe network. Look at the physical reality of this escalation. The pipe diameter is now reduced by 22%. The physical friction inside the pipe has increased dramatically. The fluid just can't move like it did before. Sensors are actually detecting turbulence now. The system is generating friction purely through its attempt to observe. In our human networks, this is the equivalent of massive integrated surveillance operations. Think a vast corporate monitoring software that logs every keystroke, or citywide camera networks. The system begins to collect basically infinite perfect compliance data. On paper, the system looks incredibly healthy. Everyone appears to be following the rules perfectly.
but that's because the sensors only record what is visible, and the visible behavior has been strictly self-policed.
But here's the fatal contradiction. As the system collects infinite compliance data, it simultaneously loses all error data. In complex, high-stakes environments, like hospital units or massive engineering projects, small mistakes, minor deviations, and process errors happen constantly. But because the monitoring is so impossibly dense, the perceived risk of admitting a mistake becomes way too high. The subjects simply stop reporting critical deviations. The system thinks errors have completely stopped occurring, but in reality, they've just gone completely underground. Section 4. The safety mechanism. So why exactly do the subjects stop reporting? We need to look at the core structural constraint that the monitoring system is unknowingly destroying. The crucial point here is a mechanism known as psychological safety. It's defined as the belief that one won't be punished or humiliated for speaking up with ideas, questions, concerns, or mistakes. And listen, this isn't just some feel-good corporate buzzword. It's a vital structural input absolutely required for systems to self-correct. It functions as a load-bearing pillar of the system's architecture. For instance, research into hospital units shows that when team members genuinely believe they won't be punished for reporting mistakes, the reported error rates are actually higher because they catch the errors before they become fatal. But heavy monitoring structurally annihilates the safety mechanism. As monitoring spikes, the perceived risk of speaking up increases exponentially. In a highly monitored environment, every admitted mistake is permanently logged, analyzed, and potentially punished. Therefore, the completely rational, local decision for any individual in that system is to just stay silent. Psychological safety drops to absolute zero, and the system's ability to learn from its own mistakes is completely severed. Section 5. Structural lock-in. Now we reach the critical phase. Let's see how this builds and why escape from this cycle becomes structurally impossible for the system. We observe the final state of our physical pipe system. In a desperate bid for total clarity, the operators have now attached 200 diagnostic sensor clamps. The physical lock-in is now irreversible. The cumulative compression from 200 clamps has reduced the pipe's diameter down to 0. The flow ceases entirely. In its quest to perfectly monitor the flow, the system has physically crushed the very thing it was built to measure. Returning to the real world, the system is now experiencing cascading failures it never predicted, all because the tiny errors were hidden from view. And how does the system react to this lack of reporting and sudden failure? Well, it behaves entirely rationally based on its programming. It assumes it simply doesn't have enough data. It assumes the existing sensors just aren't good enough. So it mandates better, deeper, more pervasive surveillance. It adds more clamps. Mathematically, high monitoring density directly correlates with low honest error reporting. They are inversely proportional. The rationale, local optimization of visibility, that desperate desire to see absolutely everything, mathematically destroys the honest feedback required to survive. The system literally chokes on its own surveillance. And this leaves us with our final irreversible realization. When a highly monitored system inevitably collapses due to unreported catastrophic errors, it's so easy to blame the humans for hiding the truth. But the humans were just behaving rationally within the constraints of their environment. The system didn't fail because it was broken. It followed its structural logic perfectly. It optimized itself step by step, sensor by sensor, into total, inevitable blindness. So, what other systems in our world are currently tightening their clamps? Think about that.